Okay guys, I know it's been a while, but I finally got back some gear so I can actually make back these videos once again. So it will be a continuous process. We'll be having some classes in school as you prepare for your CSEC, and I'll be home here making some videos to assist you in your preparations. So one of your colleagues sent me this question earlier tonight to just give them some guidance. So this is what the question states. The diagram below shows triangle PQR in which angle QPR equals 62 degrees, angle PQR equals 90 degrees, and PR equals 11 cm. So of course you see the triangle labeled there, and of all, for the sake of a little bit of explanation, whatever letter is in the center relates to the angle that you have. So wherever you see P, that's why you see 62 there, which is here. And we see here is Q, so Q at the bottom here. That's why we have the 90-degree indicator here. Good. And we have PR 11 cm. So P to R 11 cm, or we can even say R to P is 11 cm. Either way works. Good. So with that being established, now let's move on to the other areas that we need to focus on. So we are asked to calculate the size of angle PQR. So when we think about this here, the sum of angles in a triangle is equal to 180 degrees. So a triangle, when we add all of the angles together, we need to have 180 degrees. So we are solving then for, if you look here, R. So little question mark here, or double question mark, because this is what we're solving for. So what do? Well, when we think about it, a triangle has three sides, and we know two of the sides. The sides are my 62 degrees, which is at P, and my 90 degrees, which is at Q. So using that information there, 62 degrees plus 90 degrees is 152 degrees. And when we now consider that we have two and we need one more, it's 180 degrees, which is the sum total, minus 152 degrees, which is equal to 28 degrees. So that's the first part. So notice that this is just a basic approach to actually solving, and let's move on to the next part now, where we're asked to solve for the length of the side RQ. So here is RQ. So that's our side we're working on. Now, with that being our focus, we need to now pay attention to what we're given. Here's the hypotenuse. But then we now run into a little bit of an issue, like, so where's the opposite? Now, the opposite is always opposite the angle. So this is the angle that we have. So if we draw a line coming all the way down, this is the opposite, making this side here the adjacent. So if you remember, some old horses can always hear their owner's approach. So let's just do a little game of elimination to know which of these formulas we need to make use of. Now take note, we know the hypotenuse, so tan no longer applies. Now we have the opposite and the hypotenuse. Opposite and hypotenuse. So cosine is gone, leaving me just with the sine ratio. So we're going to say sine theta is equal to the opposite over the hypotenuse. So sine, now the angle of course is going to be opposite the side we're working with, which is 62, is equal to the opposite, which is going to be RQ over the hypotenuse, which is 11. Now notice this is what we're using as the divisor. So we're going to take it over and we're going to do the opposite. So opposite of dividing is multiplying. So we're going to have sine of 62 times 11 is equal to RQ. And of course, when you enter this in your calculator, which I'm going to show you, when we do sine 62 times 11, we have 9.7 and all these behind. So let's just use one decimal place. Here is 9.7 is equal to RQ. Yes, and that's how you go ahead and actually solve this question. I hope you find this helpful and continue with your studies.